work in process, or sometimes, as you'll hear it, called work in progress. And we call this work in process because you're not always necessarily making progress. And we'll talk a little bit more about that here in just a moment. So we largely work in large organizations. We do complicated projects. And a lot of times, those projects entangle different streams of work. We have different functional stakeholders who we rely on, different projects, and people in the program office sometimes compete for resources, and it can just all turn into a bit of a mess, right? So what we end up with is a situation where we have tons and tons of work in process. And so some we're going to talk about today. We talked a little bit about during the last presentation on lean portfolio management, and that was a little bit more from sort of a program and PMO point of view. But today we're really going to drill down on the concept of WIP itself, which is pervasive across lots of different areas, not just at the program or portfolio level, not just at the project level, not just at the team level. It's a very pervasive and sometimes insidious dynamic that applies all over the place, right? So want to lead with a few assumptions and a few goals for the next 45, 50 minutes or so. Just as a point of interest, I'll share with everybody, I came to my understanding of work in process as as a little bit more than just a surface level topic. When I got involved in the DevOps world around 2014, 15, so about 10 years ago. And the thought leaders in the DevOps community, a few of whom I will mention here in just a moment, they really got into this concept of WIP, and they analyzed it and came up with some pretty cool perspectives and some pretty cool strategies for dealing with the downsides of it. But WIP is certainly not just a DevOps thing. WIP is something we talk about at all kinds of levels, right? The next assumption here is, I want to be clear about this, there's no silver bullet in this presentation. So this presentation really is more of a baseline on the concepts and sort of the fundamental organizational dynamics of work in process. I will give you some strategies that can be applied, but it'll be kind of up to you to figure out how to apply them, and maybe more specifically, how to get people on board with applying them. And then, as Laura said, please do chime in the chat, ask questions as we go. There's a lot to cover here today, so I'm not sure we'll really have like a big chunk of time left at the end for a Q&A period. So I'm happy just to address points or address questions in the chat as we go along. So please don't hesitate to ping me in the chat, and I'll keep an eye on that. And then I'm going to drop some names for further reading here in a moment. So today's agenda, we're going to talk about WIP at a high level view, how it impacts teams, flows, and efficiency, some of the dangers of WIP and how it slows us down, and then a few ways to manage work in process. We're going to talk quite a bit towards the end about Kanban as one of the key ways that we can address WIP at multiple levels. We'll talk about ways to make work visible. We'll talk a little bit about batching and queuing, and finding and elevating constraints. This is sometimes referred to as the theory of constraints, introduced in a famous manufacturing book called The Goal. In the chat, we have a question: does WIP include two? A great question. I'm actually going to talk a little bit about that in a moment. So I think that the short answer is yes, absolutely. If work has been approved or green lighted and it's in the queue, then that is absolutely WIP, in my opinion. And that's actually a very good question, something we'll talk about here in a moment. And then finally on our agenda here, we're going to talk a little bit about some concepts pulled from the Phoenix Project, written by Gene Kim and his co-authors. And we'll talk about ways to identify high value versus low value tasks, right? So that's the agenda. Those are the assumptions. I said I was going to drop some names. Let me go ahead and do that. So I already dropped Gene Kim's name. Gene Kim wrote the Phoenix Project and has been involved in multiple other books from the DevOps world. Same with Jez Humble. Jez Humble famously wrote the book along with along with David Farley in 2011, continuous delivery, which is a sort of a technical roadmap for setting up CI/CD and automated test pipelines. And then together with Barry O'Reilly and Joanne Molsky, wrote sort of a follow-up book to that called Lean Enterprise, in which he kind of dealt with the organizational hurdles of actually implementing the type of automation and continuous workflow concepts that they introduced in continuous delivery. Don Reinertsen is the king of queuing theory and batch theory, wrote a lesser well-known, but probably in some ways even more substantive book called The Principles of Product Development Flow. And that's an excellent book, chock full of technical methods that you can use to manage WIP, manage queues, manage batches. So I'll talk about Don a little. Josh Arnold is a consultant out of New Zealand that I've followed for quite some time. He deals primarily with flow and flow rates and optimizing flow rates across systems. And then John Willis is another luminary from the DevOps world. We've had the pleasure of hosting John at several of our DevOps Days conferences that we organize here in Raleigh. And so I'll throw him out there as well. John Willis, in particular, just wrote a new book that I'd be happy to plug here for a moment, called Deming's System of Profound Knowledge. So this is kind of a biography of W. Edwards Deming, who really is sort of the grandfather of a lot of the concepts we'll talk about here. So Gene Kin, let's talk about Gene first. Gene wrote the Phoenix Project, which was the book that really catapulted the DevOps movement to the bestseller list and led to every IT tool and automation company in the world scrambling to kind of adopt the types of work patterns that he introduces here. But the Phoenix Project is kind of a reimagining of this book, The Goal, that I mentioned. And basically, the thesis in the Phoenix Project is that he draws parallels between IT work and the type of project and product management that we do in an IT shop or a knowledge shop professionally. He draws parallels between that and the world of manufacturing. And so as it turns out, the world of manufacturing had a lot of the same challenges that we face today in the world of IT work. And not just IT work, but any type of work that's invisible, technical work, knowledge-based project work, and things like that. And so he drew parallels between this and a lot of the same issues that we'll talk about here. Excuse me, a little sip of coffee there. They dealt with in the world of manufacturing. And so he kind of takes the lessons from the world of manufacturing, and a lot of this was around the total quality movement that came out of Japan and the quality revolution that we had here in the U.S. kind of like in the early 80s or so. If you remember anything about the United States automotive industry, the U.S. was kind of notorious there for a while for poor quality. And a lot of the poor quality that was coming out of those production systems arose from the same kinds of challenges that we have here. And a lot of those challenges, it turns out, were directly related to WIP. And so they came up with ways to manage that in manufacturing. And so in the Phoenix Project, Gene sort of reimagines those for modern workflows. But he introduces this concept in the Phoenix Project of what he calls the three ways. And then he kind of builds the management parable on the three ways. And these are the three ways as Gene presents them. The first way is flow. The second way is feedback. And then the third way is continual learning. So it's quite soft sounding things there, a little bit abstract, you might think. But he really presents some high level techniques for implementing ways to manage these things. I've given a few examples here. When he talks about the first way, what are we talking about here? We're talking about the way that CI/CD style work reduces our batch sizes and gets those segments of work flowing along way more frequently and in much smaller sizes so that we can do things a little bit more continuously. So instead of doing things in a waterfall fashion where we have a big plan and then we put that plan together, we're sort of continuously testing, continuously deploying. Same thing with agility. Measuring the flow of business outcomes. Business outcomes is really one of the key things to think about here in terms of measurement. We want to make sure that OKRs and KPIs are measuring effect flow activities. So a lot of times, we make the mistake of measuring activities, hours, time cards, the number of units of work done, or the number of user stories completed, things like that. Now, it's not that it's not a good idea to measure those things, but those are not the end all be all metrics, right? Like ultimately, we want to have the business outcomes qualified, and we want to have ways to measure those. So from these examples, then Gene moves on to feedback. This is obviously just about communication, measuring how things behave, measuring the things that we're doing, and then getting feedback back upstream so we can learn lessons, which leads to the third way of continual learning. And he doesn't just mean sort of abstract learning of these lessons. He's talking about actually setting up disciplined, scientific ways to perform experiments and collect data, do A/B testing and things like that, so that we can actually understand and learn from a technical level what does well, what can we improve, and things like that. So the first way is the one that we'll really kind of focus on for today, and this is the way of flow. So when we think about work in process, we're really dealing primarily with flow. And so in the Phoenix Project, Gene mentions these 6 principles. And these 6 principles are the ways that we can increase the flow. Now, we're interested in increasing flow, obviously, because then we're operating with more efficiency. We're getting more bang from the buck from the people doing the work. And then above all, we're getting more output, and we have the capacity to do more work. So when we think about work in process, we're really trying to, we're not necessarily trying to maximize the amount of work in process. We're trying to maximize the amount of work that we get out of process and get over the finish line. So these 6 principles are how Gene presents it. Make things visible. Now, lots of work that we work with are kind of invisible. It can be hard to track. Limit WIP. You can do this by reducing the batch sizes, reducing the number of handoffs, find and elevate the constraints. I'll talk a little bit more about that. And then find and eliminate waste in your value stream. So if you're going to eliminate waste in your value stream, you've got to be able to visualize the value stream. So this next little series of diagrams here, I use this a lot. So if you saw my presentation on the LPM, then you probably saw this, or the presentation on the fuzzy front end. So this is just kind of a sample way of visualizing a development value stream, very generic value stream in an organization. Now, there may be different ways to come at this. These could be departments, they could be roles, or they could just be things that need to be done to the work, regardless of how the teams or the work is actually organized, right? So this is not an org chart per se. It's not a departmental diagram, although it can be, but one way or the other, these functions have to be done, right? So we generally start with the need, and then we don't really have any value until there's delivery, because everything up to the point of delivery is overhead. This is sunk cost. So we got to get to delivery, get things into operation, the production environment, and then hopefully collect some feedback here. So when we're collecting the feedback, that goes back up and informs the front of the value stream. So, and then I'll highlight delivery just because, as I mentioned, this is a very special step in the flow. And what you notice is that this step happens pretty close to the back end, the downstream point in the value stream. So, but until something is delivered, there's zero potential for value. So we want to get things through this cycle and across the finish line of delivery as quickly as we can, which leads us to one of the first insidious wastes of work in process, which is waiting. Now, how do we know that we're having to wait a lot? Well, we know this because if we visualize that workflow that I just showed, and then we visualize how much time each the units of work actually spend in one or the other of step, and then we map how much time it spends in those steps, then we can get a little something like this for you. So this is a sort of an alternative way of looking at that workflow, right? So if we think about that feature, spends in that particular part of the work stream, and then you map that value stream, what you can see is kind of what we're doing when work is actually being performed on the feature is here in green. And then we've got a 40-day cycle here for things to matriculate through these functions. And a lot of times what we see is the majority of the time is spent just waiting on that feature's turn to be worked on, because we've got often kind of a first in, first out system. And so a testing team or development team or deployment delivery team, release team, they're busy deploying, testing, developing, and releasing the features that came into the department first, right? So dynamic ways of prioritizing. Sometimes this happens to more or less degree. You know, frameworks like SAFe attempt to address this sometimes to more or less success, depending. But the big point here is that a lot of features spend a lot of their time just waiting to be done, and waiting is an insidious waste. There's no value-added work being done. So the other thing we can see, if we pull some information from Gene Kim here. This is drawn from Gene's blog on IT Revolution Press. We find something very interesting here. If we map the amount of waiting time that happens when a department or a resource is busy, what we find is that as a team or an individual or a department or really anything approaches their full capacity, then the waiting time increases exponentially. And so Gene has mapped that for us here. And so, what we find is, when you're at like 90, when you're up to about 90, 95% busy, things aren't really all that different than having hardly any work to do at all. Work flows through the department very quickly. Things are quite efficient. But as soon as you get above that 95% mark, all of a sudden your waiting time spikes, and you're waiting a lot more time for something to get done. And this is interesting because if you work with development teams, software teams, testing teams, or in particular IT teams, IT support teams, who has ever dealt with somebody like that? And those folks are only 90% busy. So just think about that for a minute. So there's too much WIP here, right? If you are having to wait a long time, this is why, something that it seems like it should only take 15 minutes, you have to submit a ticket and then you wait a month for it to get done. That's why this happens. And a lot of us are familiar with the frustration of that dynamic. So this happens because of full capacity. And so when teams, departments, functions, projects, products, when those development streams are maxed out, then the flow gets really slow. And we can visualize this just like we see in this photo here, right? Everybody's familiar with rush hour traffic and just how slowly things move, which is a little bit counterintuitive. It's not as counterintuitive when you see it visualized in a photo like this, because we've all experienced this, but we don't always visualize the equivalent of this state in terms of how much work is flowing through our system, our enterprise value stream. But the same dynamic is at play, right? If the whole system is crammed full with as many items of work as possible, then things are going to flow through that system very slowly. So this is the second fundamental thing to understand about work in process. So we talked about slow flow because of full capacity. We talked about the relationship between waiting and waste. And then here I'm going to introduce the idea of queues. So in our system, when things have to wait, then the only way to really manage that is with queues, or getting in line to wait your turn. And so there's one of my luminaries who I absolutely love is this gentleman that I mentioned at the beginning, Don Reinertsen. And Don wrote this book here that you can see, but Don is the king of queuing theory. And so he really goes deep on how to manage queues efficiently and how to optimize things so that you reduce wait times and you reduce the amount of waste that is baked into the system because things are queued up. So check Don out here. And so Don has a metric that he likes to use called cost of delay. And so when he analyzes how much time a work item spends waiting in a queue, what Don says is what you should really be measuring first and foremost is how much is it costing you to not get something delivered, to not get a feature live, to not get a product out the door. And usually there's ways you can kind of qualify that a little bit. Well, we project X amount of revenue, or we project X efficiency gains because users are going to adopt this new feature. So there's usually ways to measure that, and then you can apply that napkin math to, okay, well, if that's not being used, it's not being completed, what is the cost of that? So that's what Don refers to as the cost of delay. Don feels like the cost of delay is one of the most valuable metrics that you can use to prioritize units of work in your system. And then you can thus sort of more intelligently organize your queues so that you're prioritizing higher value things against lower value things. Even if a lower value thing came into the queue earlier, just because something got there first is not the best measurement for whether or not it should be prioritized. The cost of delay is. So that's the key concept from Don. Now, the next fellow that I'll mention here is Joshua Arnold, who I mentioned at the top. Josh really builds on some of Don's concepts, and he takes the cost of delay and he kind of takes it one step further to what he calls a CD3 score. Now, if anybody works in a safe shop, you've probably heard of this WSJF kind of rubric that they use to prioritize things, weighted shortest job first, which is okay, but CD3 is a better way. But CD3 is cost of delay divided by duration. So it's kind of the same concept in spirit as weighted shortest job first, but it's a little bit more lightweight and it's a little bit more intelligently applied. But the idea here is that you can kind of weight the work for things that are easy or fast to do, and then you kind of combine that with some weighting around cost of delay, and then you've got a really good little algorithm that you can use for figuring out what do we really need to get delivered, what's going to give us the most value, the most bang for the buck, and you can prioritize things that way so that you're getting your most valuable work out of the WIP process and into the hands of your user and delivered, so that you can actually start realizing the value of that stuff. One of my other favorite thought leaders here is Jez Humble. Mentioned Jez's book at the top here. And so Jez, it was interesting because he literally wrote the book on continuous delivery, but then when he started getting consulting calls to come in and show downstream IT teams how to implement the types of automation and continuous testing and things like that he wrote about in continuous delivery, when they went in and analyzed the workflows of his consulting clients, what they actually found was the things that were slowing down the flow of the work the most was what Jez calls the fuzzy front end. And Josh refers to this as well. So Jez, you can find videos online where Jez is giving conference talks, and he talks about this thing he calls water scrum fall. And so this is kind of a related diagram to the one that I showed before with the sequential flow of work through a feature development system. But if we look at it from a little bit more of a broader enterprise level instead of just the development lifecycle, you can see that these are usually things that are involved in getting work through, right? So usually we have some study, we have some approval. I'm involved in a project right now, which is basically a 6-month study just to kind of evaluate what the plan is going to be. Then those things have to get approved, and then we're designing and planning something. Then this is where our quote unquote agility practice usually lives. At the team level, at the software level, in which there's still usually some analysis, requirements development, and then we actually build the software, we test it. So we may be iterating on this. And then after delivery from out of development, then we're getting into downstream IT. This is where we sometimes still have a centralized testing team, although, thankfully that's becoming a little less common. I think the idea of testing as we go and shifting left has been catching on more over the last few years. This is downstream IT, QA testing, and then finally things get released. So this front part up here at the PMO level, before development or building actually starts, where we're just kind of studying and getting approval, this is the part that Jez and Josh call the fuzzy front end. And we did a whole we did a whole webinar just on the fuzzy front end a few weeks ago. So you can check that out on the SoftEd website if you want to. And then kind of down here, this often is all still waterfall, right? So it's still kind of a first in, first out, phase gated, sequential way of managing the work. So water, scrum, fall. Now, if you look on Joshua Arnold's website here, and I've provided the link, there's a very interesting case study. And the case study focuses on the world's largest maritime logistics company, Maersk, a giant shipping company here. The case study is very interesting. So this was a case study in which Maersk commissioned a team to come in and analyze and then refactor and rebuild their main one of their main IT systems. And so it was sort of a big bang project. They were looking at ways to try to optimize and do a lot of the things that we're talking about here. And you can find this case study online at Black Swan Farming if you want to, and it's referred to across the internet and some other areas as well. But what they found when they went in and analyzed Maersk's backlog was here we've got about a little over 70 features that were in their backlog in the form of requirements. And so what they found was when they went in and analyzed these requirements in the backlog, what they found was a very low number of features were the things that had a really high cost of delay. So in other words, basically there's kind of a power law curve or an 80-20 rule, which no surprise, to people in our line of work, we shouldn't be surprised that requirements backlogs follow an 80-20 rule. The Pareto principle is ubiquitous, and it applies particularly strongly in these situations where 20% of the features are really responsible for 80% of the potential value. But the thing was that for Maersk, the backlog wasn't organized according to that value. It wasn't prioritized that way. It was just prioritized in kind of a first in, first out fashion. So a very small number of features were the highest value, and then there were all of these, the remaining 80% of the features were only responsible for 20% of the value, or in a lot of cases even less, as you kind of got to the long tail here. So the case of Maersk illustrates another insidious problem of work in process, which is that the value priorities are out of order. The rubrics that decision makers are using to prioritize according to value, those rubrics are not the best. And so what you end up with is a situation like this, where it's first in, first out. And so all this long tail of features, because they were submitted to the backlog first, they were prioritized according to something that is not quite as rigorous of a qualification of value. These features here in the long tail, they have a place in the queue ahead of these, when in reality what you really got here out of 70 odd features, you've only got really 3 features that should just be swarmed on. And so indeed, that's exactly what they did at Maersk. They reorganized this so that they were visualizing the workflow in this type of way, and then they swarmed on these top 3 most valuable features as they refactor the system. So hopefully that makes sense to everybody. Now you can think of that, all of that lower value work in the backlog as inventory. And this is getting back to the Phoenix project and the reimagined lean manufacturing lessons, which is that this is another form of waste. So anytime you have product just sitting there, not moving, not getting delivered, not generating any revenue or sales or usage, then there's no value being produced, right? You've invested money, you've invested overhead, you've invested time in building this stuff, but it's just sitting there. So excess inventory is another form of waste. And so when we look at the queue here, we can think of this as excess inventory because we're not actually moving quickly on delivering that stuff. So excess inventory and work that's sitting in queues is another form of waste. So what can we do about this? That's the segment here, just kind of on the fundamental principles of WIP and some of my favorite ways to think about it. So let's think about what we can actually do about it. So the first thing that has gotten quite popular, which I'm glad to see, is to use a technique like Kanban to manage work in process. And if you guys have worked for long in an agile shop or in a safe type of framework, then those frameworks use Kanban at multiple levels. And that's one of the cool things about Kanban is you can use Kanban as a technique to manage your flow of work, either at the individual level, the team level, the sprint level, the product level, the program level, the portfolio level, all the way up to the enterprise level. And it's just kind of orders of magnitude of different ways of organizing. But in every case, we're using Kanban to kind of organize this. So, in its simplest way of understanding Kanban, it's basically a way of, number one, visualizing work. Because if you remember from Gene Kim's first way of flow, you have to visualize and see things before you can start to get your head around how they're impacting the flow. So it's basically just waiting to be done. This is kind of our to-do list on the left. Then we have an in progress doing column, and then we have a done column. That's the simplest way. But then now, this example that I'm showing here is probably a little bit more realistic of a Kanban board for the type of work we do, in which case we're kind of breaking things down both at an epic level and a story level. We have different lanes here, and then we have different classes of service applied here. And classes of service are rules that business stakeholders and decision makers can make for us, which stipulate, this is a way of ranking how important something is, even if it comes in after the fact, right? So if we have in progress work that's being done, but then there's some kind of a critical outage, or there's some new feature that we recognize we really need to get out to market faster, then we can apply class of service rules to those types of items so that we are prioritizing the newer thing, even though it came in after. And then there's also classes of service where we can apply limits to the work in process, and that's a key concept. As Gene says, limit the work in process so that you don't get your capacity full and everything slows down. So hopefully we see the logic of that at this point. So we need both upper and lower limits on our work in process. So we make sure people are staying reasonably busy and they're getting a reasonable amount of work done, but there's a cap on how much can be in process at any one point. And as we can find, actually when we limit the amount of batches that are flowing through the in progress stage of work, then actually those batches flow through much faster. And then we actually kind of, the math is working in our favor there. So Kanban is the main way of managing work in process. So I would suppose we ask ourselves these questions. What kind of work are we doing, right? So let's think about a few different scenarios here. In one case, we're building a large material-heavy project like a freeway overpass. In the second, we're delivering software. And then the third, we're treating patients in a hospital emergency room. So in the first case, you can see that your work involves very clear specifications, and we have a really high material cost, and we have a really high cost of change. So that's the first example. Now, in the second example, the software example, we have relatively unclear specifications. However, our material cost is really low, and the cost of change is really low. Software is just code. I mean, it's really easy to change. If we identify a requirement that has shifted, then it's really cheap and it can be really fast to make that change as long as we manage it correctly. Whereas with a freeway overpass, if we change a requirement after $500,000 worth of concrete is poured, then that's a really different situation. And then in the third case, treating patients in an emergency room, the key thing is unpredictability. Things are always changing, and prioritization has to be dynamic, and it's mission critical. So if you have a full emergency room full of patients with broken arms, it's important to treat all those people, and they may be queuing up in kind of a first in, first out way. But then if you all of a sudden have a car accident and somebody comes in with a traumatic brain injury and they only have minutes to live, you got to get those people to the front of the line fast because they're going to die otherwise. So that's the kind of dynamic that we're working with in the most exaggerated sense. Should you use the same process for each situation? Obviously not, right? So in these examples, the first example of the freeway overpass, that's a situation where, more of a conventional waterfall type project management is entirely appropriate. If we have a high material cost and a high cost of change, we can qualify those costs, and we can afford to be a little bit more deliberate and spend a little bit more time making the plan. But in the second case, we are wasting time if we spend tons of time before we start building planning, because things are just going to change anyway when the specifications become more clear, and we need agile ways to accommodate those emergent requirements. And then in the third case, the priority here is having a really dynamic way to order what's important. And things are really critical. So basically, the takeaway here is Kanban is a great way to organize work in the second and third case. It can still be utilized in the first case, but it may not be the central project management or product management technique. So the main goals of Kanban are, as I mentioned, to make work visible, to put limits on each lane or each column of work, so that we're managing each phase of work as it matriculates through the system more intelligently, and always measuring so that we can, again, make things visible and expose that data, because people are going to learn. There's going to be a knowledge dividend if we're able to expose that data. Explicitly defining our policies so that we have rules to follow and people's expectations are clear. Setting up disciplined and structured ways for feedback loops, and then doing experiments, as Gene mentioned, right there in the first way of flow, so that we can see, and collect disciplined quantitative data on what's working well and what's not working well. A few things Kanban is not. It's not traditional project management. It's not a rigid methodology. It's essentially a process improvement framework. It is not a project management prescription here, right? It's something that you can sort of work in. It's not a specific agile method that you're going to install. It certainly is not a lack of discipline. And finally, it's not a perfect solution. There are some use cases that Kanban is not really going to help you do, right? So if your problems are around architecture design, testing, or writing requirements, those are not good fits for Kanban. So a few of the things that Kanban is not designed for here. But Kanban can work really well in these situations. When we have large, uneven batches. Just like in the emergency room example, we have unplanned, disruptive requests that come in unpredictably. It can also work well when we have blocking issues that hold up the line, hold up the queue, and keep us from getting things done. Now, when we have a situation when deferred commitment can be desirable, right? So dynamic priorities, and as in the emergency room case, we need a dynamic way to constantly replan, reshuffle our priorities. We have high rates of, lack of adoption. We work on things and then that piece of work is deemed not to be appropriate any longer or not to be valuable, so then it gets abandoned. It's a good situation for Kanban because we want to find ways to limit how much of that upfront investment is done, and if the work's ultimately just going to get abandoned, right? Sorry, flipping around my slides a little bit. Corollary to this is delivered work that never gets adopted. So we want to figure out ways to intelligently defer commitment in those situations, because those are spending our time, it's spending our team's resources doing work on things that ultimately are not going to deliver any ROI. And then there's a human side to this, in which we can use these signals as good indicators of situations where Kanban may be a good candidate for managing work. We've just got too much whip. Things aren't getting completed because it seems like we have a gazillion things in process, and you can tell some symptoms of this. So people are overburdened, they're overworked, they're stressed, they've got too much to do, they don't know how they're going to handle it all, they're overwhelmed. This results in poor quality when things do get delivered. And then finally, of course, we have long lead times, long queues. So things are spending a lot of time waiting. So if you recognize any of those systems, then those are just good indicators that, hey, you could probably improve your process with a step like Kanban. Now, the other thing I want to mention here in terms of, and this is not explicitly a Kanban thing, although using Kanban can help you do this, is this idea of the theory of constraints. And so in the theory of constraints, what you're doing is looking for a bottleneck. Now, Kanban can be a way to visualize and detect the bottleneck. Value stream mapping can also be a good way to detect the bottleneck. So like if we go back to this value stream illustration here real quick, go back. So many slides ago. So if we look at this value stream, this is a good way to identify bottlenecks, right? So we can see there's multiple bottlenecks here. Bottlenecks where we're doing the feasibility study and everything else is stacked up waiting. Bottlenecks for development, bottlenecks for QA, a little lesser so here, but certainly with feasibility. And this is the fuzzy front end that we talked about. Lots of ideas, lots of potential valuable things that we want to build, but feasibility in the studying and the approval process is the bottleneck there. So if you find the bottleneck, then the nice thing about identifying that bottleneck is that you really only have to worry primarily about that constraint. That's the essence of the theory of constraints, right? Is that you really just find the bottleneck step. And it's sort of like the idea that a chain is only as strong as its weakest link, right? Flow through a system of work is only as fast as its slowest, most choke-pointed step. So if you find that constraint, you can institute improvement processes or project work specifically just to improve that constraint, that bottleneck, because that's going to unlock greater flow for the whole entire system. So there's always a constraining step, right? There's always going to be something that's creating the bottleneck, something that's slowing you down. And so the theory of constraints is just a process of identifying whatever your greatest constraint is, elevating that constraint and exploiting it so that you speed up the flow of work through that particular choke point. That's going to increase the flow for the entire system. Once you've addressed that and you've figured out ways to improve it, then you can go on and find the next constraint and the next and the next and just keep on doing that. That's how we continuously improve the flow of work through our system. So some lessons from Kanban here and to a lesser degree, theory of constraints. What are the lessons? And these are lessons that should inform the ways we design business process to manage these types of issues. Number one, pull work instead of pushing it on the teams. So I'll talk a little bit more about that in just a second. But if you have a well-prioritized backlog, then the work is sitting there ranked by value. Maybe you're using cost of delay to rank it. Maybe you're using a CD3 score or something like that. But whoever the decision makers are kind of upstream in that fuzzy front end, which we are hopefully going to get a little less fuzzy, that work, those features, those things we need done are prioritized, and the decision makers have already prioritized them. So they're sitting there in a nice prioritized stack. And then as teams have capacity, as their part of the Kanban board passes something along and they're ready to work on something else, they can pull from the stack and they don't have to waste time figuring out what's the most important here. How do I prioritize? Somebody else is prioritizing things for them, and they just pull from the stack and they're ready to roll. That's a pull-based system instead of push. So one of the things that Kanban teaches us is that if you can institute a pull-based system so that work is continually being pulled from downstream rather than pushed from upstream, that's way more efficient. So that type of approach promotes a much better, more optimized flow, often even more effectively than other agile practices. And then remember the slide from Gene with the exponential weighting. Another lesson here is that if you can keep some capacity in reserve, then you're way more nimble and you're way more able to adapt, when that traumatic head patient comes in from the car wreck, it's going to be you're going to be a lot more flexible, able to pivot to the way more important thing. Same principle applies here with our teams. Try really hard to institute upper work in process limits so that they're never more than like 95% busy. 95% busy is plenty busy to be, right? Like our teams are going to actually deliver a lot more value if they're 90 to 95 or less percent busy than if they get above that full capacity for the reasons we've discussed. And then the next thing here is just transparency. Make sure that everything is completely transparent via data. If management and decision makers and leaders are seeing the same set of metrics that the teams are, then the teams know how they're being measured. The leaders have a lot more visibility into the performance and the efficiency of the team. It's just in everybody's interest to have shared metrics. And then another thing that Kanban allows us to do is to assign owners to things. So whether that's a person or a team, in SAFE, we may have other people who are responsible for product or portfolio level Kanbans, but we want to have ownership there, right? Like if everybody's responsible, then really nobody is. So it's important to have owners, and in our Kanban system, we can assign those owners and make that visible. So people have questions, they can see on the Kanban board who's responsible for this feature, this batch, and then as problems arrive, they knew who to ask. So the other thing about Kanban is that it's not intended to fix everything overnight. It's not intended to be a big bang transformation. It's intended to be a continuous improvement process. So one of the fundamental values of Kanban is that you just start where you are, do some of the things that we're talking about, find and elevate just that one constraint, find that one increment of improvement that you can make, and then go from there, rinse and repeat. Now, there's a few responsibilities that I alluded to. These are from the business decision maker's side. It's the responsibility of the business decision maker to find a way to quantify, or at least to qualify, the value of the outcomes, not the value of functional requirements or technical requirements, but the value of the business outcome that those requirements, that feature is intended to support. So that's a business decision maker's, a leader's job, is to find a way to qualify that value and then communicate it in a way that everybody downstream can understand. And then I talked about this for a moment just a minute ago. It's the responsibility of the business to relentlessly prioritize those outcomes so that people understand, everybody has a shared sense of mission about what the most important thing to work on is. And then they need to make those decisions, the decisions about the value, decisions about how to communicate the value, and then decisions about how to prioritize the business outcomes. They need to make those decisions in a way that's optimized for time, right? So there are lightweight, fast ways to make these decisions, but if they're gonna stay ahead of the teams who are downstream from their decisions so that you can take advantage of this pull-based flow of work that we're talking about, they've got to stay ahead of that. So they've got to have those priority decisions made before the team is ready to understand what's next. So these three things are main responsibilities of the business decision makers. These three things are not the responsibilities of the business, and these are common anti-patterns that you may see. So if you see these anti-patterns, then you know that there's a better way to do things. So tying performance metrics or people's performance reviews to revenue goals, that's not a good way to match up KPIs. Asking the teams to estimate about how long something might take, and then turning those estimates into deadlines and holding teams accountable to those deadlines. A lot of times we're going to find teams will hedge, or they're reluctant to even estimate, even though a project manager or someone from outside their department presses them to give them an estimate. Hey, I just need to understand how long this is going to take. Please just give me a rough estimate. As soon as that estimate gets articulated, then, as sure as the day is long, somebody's going to hold them accountable to that, and it's going to turn into a deadline, even though that was never its purpose. So that's an anti-pattern. We don't want that to happen. And then finally, implementing OKRs or KPIs by things that are essentially just activities, like meeting deadlines or the number of user stories completed, things like that. Again, as I mentioned earlier, I'm not saying don't measure those things. I'm just saying those are not the ultimate measures that we want to pay attention to, because what we ultimately want to be measuring is the value outcomes. So once things are delivered and we can actually collect some performance metrics, some usage metrics, some ROI metrics, those are the types of OKRs that we want to measure. And then the final point that I just want to make very briefly here is one of the main ways of managing or increasing the flow rate, especially in an IT system where we can automate a lot of stuff. Work in process shares a really unique entanglement with the concept of automation. So one of the ways that we can attack a constraint and open up that constraint is to implement some form of automation. But that creates a dynamic interaction between our constraints, our WIP, and the automation tools. And then automation tools can also create new problems and new constraints. And that's just worth mentioning. So, automation is something we could probably spend a whole webinar on, and maybe we'll do one in the future that's just about the aspects of automation that we should be thinking about. But for now, I'll just kind of leave it at this. Automation is a really important way from a tooling standpoint to open up the flow or address a constraint. But when we implement automation in one step on the workflow, then it's going to have knock-on consequences elsewhere in the workflow. And we just want to make sure we're paying attention to what those consequences are so that we can plan for that. We can communicate with stakeholders who may be impacted and things like that. So just a quick word about automation there. So that's what I've got for you today. To sum up, what are the lessons here? These are the main takeaways that I really want to leave you guys with. Number one, excessive WIP slows down your flow. That's the biggest thing. So it's not efficient. Causes frustration, causes things to stack up and wait. Waiting fundamentally is a wasteful activity or non-activity, I guess we should say. So if you've got a lot of WIP, then you're slowing down your flow. Teams should avoid overwork, and you can tell if this is happening if teams are working long weeks, putting in nights, putting in weekends. Teams seem like they're overloaded, they're overwhelmed, they've got more work than they can handle. That should be a signal that whoever is responsible for managing the way that work is organized, frankly, needs to be doing a better job. It's the responsibility of management to arrange these things so that people are not having to work in this way. And there's some really practical reasons for that, right? Like we're going to experience higher attrition rates, brain drain as people leave, job turnover, things like that. And also just frankly, it just sucks. It's 2024. We shouldn't be making people work like this. And we want to invest in our people so that they stay, they learn. The institutional equity of those lessons gets built into our human resources and our workforce so that we can take advantage of that. There's going to be a value dividend that comes from that. Next, I talk about this quite a bit. So using the theory of constraints to identify bottlenecks, these are not problems with your systems. These are actually very valuable. We want to identify constraints and bottlenecks because those are some of the most obvious and important opportunities for improvement and to increase our flow. And then make sure we're thinking not just about parts of the work pipeline where it's kind of a little easier to implement Kanban or map and visualize features and things like that. Think about that fuzzy front end. How long are things sitting in inventory before they actually get approved or delivered? And this was the question that came up in the beginning of the presentation, right from the beginning, right? Does WIP include pending work too? Absolutely. That's the fuzzy front end that we're talking about. So I hope that I have given you some things to think about in response to that question. And then finally, the impact of automation can cut both ways, right? It can solve for constraints, but it can also create new constraints, new OpEx commitments, and new impacts and things like that. So maybe we'll talk about automation at another time in a little bit more detail. That's just a little teaser for you. So with that, that's the whole presentation.